In this video, I'll be going over the Chapter 1 homework problems. So here we have the rule of 72. You're going to use this rule to approximate the following amounts. We've got three scenarios here. So in part A, it says, if the value of land in an area is increasing 6% a year, how long will it take for the property value to double? So according to the rule of 72, we take 72 divided by the percentage value in a given problem. In other words, for part A, we'll take 72 divided by the 6 from the 6% in our problem, and when I plug that into my calculator, we get 12 years. That's how long it will take for the property value to double on that land. Let's look at part B. If you earn 10% on your investments, how long will it take for your money to double? So we're going to use the rule of 72 again. We'll take the 72 divided by the 10 from the 10%, and when I plug that into my calculator, I get 7.2 years. And then in part C, it says at an annual interest rate of 5%, how long will it take for your savings to double? So we'll take our 72 divided by the 5 in 5%, and when I plug that into my calculator, I get 14.4 years. So in the next series of problems, we'll be looking at the time value of money. So I have a slide here that describes all of the different exhibits that you'll be working with. You should have read this in the chapter, and you can find this in the end of chapter 1, and you'll actually be using it throughout the semester. So as a refresher, here is a quick overview of each exhibit. 1A is for the future value of a single amount. 1B is for a future of a series of deposits. 1C is the present value of a single amount, and 1D is for the present value of a series of deposits. So you can think of 1A and 1B is for future value, and 1C and 1D are for present values, and then each have a single amount or a series of deposits or multiple amounts. So for the next set of problems, I'll be showing you how to use these exhibits in order to solve the different time value of money problems. But you can also use the Excel tool I've provided in Canvas. So if you go into Canvas, you'll find a Chapter 1 time value of money Excel spreadsheet, and you'll see here as I scroll down, there's a scenario here. Here's the future value of a single amount, and it does remind you this is based off of Exhibit 1A. It explains what that exhibit is, and then you can just plug in the information in your problem. The number of years, the interest rate, and the amount to plug in, and then anything with a dark gray box, it's going to automatically calculate it for you. So if you scroll down, here's the future value of a series of deposits, or Exhibit 1B. Again, you'll plug in the years, the interest rate, the regular deposit amount that you'll put in, and it'll go ahead and calculate in the gray boxes. If we scroll further down, here's the Exhibit 1C, or the present value of a single amount. You'll put in the number of years, the interest rate, the future amount desired. This is how much we want in the future, and the gray boxes will calculate that for you as well. And then last is the present value of a series of deposits. So again, enter the year, the interest rate, and the regular amount that you plan to withdraw. So in order to use the Excel or the exhibits, you have to understand what scenario you're looking at in order to apply the correct formulas, the correct exhibits. If you don't know which ones apply, then it won't make sense. So we'll go ahead and go through the examples so you can see how they apply. So in this problem, you're going to actually get to practice each of our exhibits. So you're going to use the time value of money tables and calculate the following. In part A, we want to find the future value of $550 6 years from now at 7%. In other words, I want to know what my investment of $550 today is worth in the future 6 years from now, given an interest rate of 7%. So our formula we're going to use, future value, is abbreviated as FV. And the formula is going to be the amount deposited. That'll be my $550 I have today, and we'll multiply it by our future value factor. So I do highlight this is where we use Exhibit 1A. Now in real world, you wouldn't have someone telling you which exhibit to be using. While I give it to you in the homework, it's so you can practice, but over time as you see this more and more, you should be able to recognize when to use which factors for which scenario. So recall in our part A, we're looking at 6 years for our time period. So here on the left is the periods. So I'm going to go down until I find 6 years. So here's my 6. And the interest rate in that scenario was 7%. So each column across the top is the different percentage values of interest. And so here's my 7% column. So I'm going to make sure that I go down where my column is 7% and my row is the 6-year period. So my factor is going to be 1.501. So when I go ahead and plug my two values into the formula, my amount deposited and my factor, and I plug that into my calculator, we get a future value of $825.55. Let's go ahead and do part B. The future value of $700 saved each year for 10 years at 8%. So it's important as you read through the problems, you're trying to interpret what was going on. So it's helpful to imagine, what does this mean in terms of money? So in other words, I'm going to be taking $700 each year, every year, and I'm going to put it into some kind of investment for 10 years, and my interest rate is at 8%. So I'm going to go ahead and use this formula. Again, we're trying to figure out the future value. This is the annual amount saved, so that's the $700 each year. And we're going to multiply it by the future value annuity factor. So you'll notice that the FV has an A at the end of it now because we're looking at annuities. So we're going to be using Exhibit 1B, and we're going to be using the 10 years and the 8% in order to find out what that factor is. So here's my Exhibit 1B. Here's my period on the left. I'm going to go 10 years down, so right there. And then the interest rate was 8%, so I'm going to go to the column that says 8% and go down until I get to the 10-year row. So that gives me a factor of 14.487. So plugging my numbers in, the annual amount I saved is $700 times the factor of 14.487. When I put those two in my calculator, we get $10,140.90. So let's go ahead and do part C. The amount a person would have to deposit today, in other words, the present value, at 5% interest to have $1,000 5 years from now. In this problem, we're making a single deposit. So the formula we're going to use is our present value deposit is our desired future value, that's the $1,000 we want in 5 years, and the present value factor. So since this is a present value formula and we're doing a single deposit, so we'll go ahead and use Exhibit 1C based on the 5% interest and the 5 years. So I'm looking at the period. Here's my going down to my 5 years. So I'm going to go to the column that says 5%, and I'm going to go down until I get to the 5 years row. So that's 0.784. So plugging in my numbers into the formula, there's my $1,000 I want in the future, and my present value factor of 0.784. Multiplying them together in my calculator, we get $784 for our deposit today that we need. Let's go ahead and do part D. The amount a person would have to deposit today to be able to take out $500 a year for 10 years from an account earning 8%. So while we're depositing something today, this problem is really interested in about withdrawals. In this case, we want to withdraw $500 a year for 10 years. And so the formula we need, again, we are interested in the deposit today, that's our present value, in order to withdraw annually the $500, and we have to multiply it by our present value annuity factor. So you'll notice again it's got a little A here, unlike the previous one, because we're working with multiple withdrawals. And so we're going to use Exhibit 1D. Again, make note, is 10 years at 8%. So here we are in Exhibit 1D. We're going to go to the period and look down until we get to 10 years. So I know I'm going to be around here. And then for the percentage, we're looking at 8%. So I'm going to go to this column, and then I'm going to go down until I get to the 10-year row. That gives me a factor of 6.71. So plugging in our numbers, the annual withdrawal of $500 a year and our PVA factor of 6.710 into our calculator multiplied together, we get $3,355 for the deposit we need today in order to be able to withdraw this much each year. Let's get some more practice with time value of money. In this scenario, we're working with the future value, or the compounded sum of a single amount. So Ben Collins plans to buy a house for $220,000. If the real estate in his area is expected to increase in value by 2% each year, what will its approximate value be 7 years from now? In this instance, we're using Exhibit 1A. And in the homework, you'll notice some rounding instructions, so make sure to follow it carefully. So the formula we're going to use to find the future value of our house is the purchase price times the future value factor. So here's Exhibit 1A. I'm going to go to the period and go down to the 7 years row. And we're working with 2%. So I go to the column with 2% and then go ahead and go down until I get to the 7-year period. And so my future value factor is 1.149. So plugging in my numbers, my purchase price is that $220,000 and my factor is 1.149. Plugging that into our calculator, we get $252,780. In this problem, we're looking at present value to be received after X number of time periods. Let's say you desire to have $10,000 for a down payment for a house in 5 years. What amount would you need to deposit today? Assume that your money will earn 4%. As you can see, in the scenario, what amount would you need to deposit today? So that's a single deposit. So we're going to use Exhibit 1C, and here's our formula. We need to know what we need to deposit today in order to achieve our desired future value, and we'll multiply it by our present value factor. So here's Exhibit 1C. Going over to our periods, we're going to go down to the 5 years, and then looking for the 4% column, and then going down until I get to the 5-year row, I get a factor of 0.822. So when I go ahead and plug in my numbers, we desire $10,000 for a down payment in the future, and the present value factor was 0.822. Plugging that into our calculator, we get $8,220 as the amount that we need to deposit today in order to achieve our goal of $10,000 for a down payment. In this problem, we're going to be working with future value paid at the end of each period after X number of time periods. If a person spends $10 a week on coffee, assume $500 a year, what would be the future value of that amount over 10 years if the funds were deposited in an account earning 3%? This is a great example of a way to assess your coffee habit or whatever other habit you might have that you're spending on a weekly basis to see what you could be earning in an investment as opposed to on something like coffee. So we'll be using Exhibit 1B because we have an annual deposit we're making, the $500 a year over 10 years. So the formula we'll be using is the future value equals our annual expense, so that's how much we're spending annually on coffee, times our future value annuity factor from Exhibit 1B. So going over to our periods, I'm going to go down to the 10-year row, and we're looking at 3%. Go to the column that says 3%, and then go down until we get to the 10-year row. So my factor is 11.464. So plugging in our numbers, we get 500, that's our annual expense on coffee, times our future value annuity factor of 11.464. Into our calculator, we get $5,732. Think about what you could do with that money if you could kick that coffee habit. Here's our last problem, the present value or annuity paid at the end of each period after X number of time periods. If you borrow $8,000 with a 5% interest rate to be repaid in 5 equal payments at the end of the next 5 years, what would be the amount of each payment? We're going to be using Exhibit 1D here. And so you'll notice though that this problem is a little bit different than the example we saw in a previous problem. In this case, we want to know what's the payment amount that we're going to be making each year over 5 years based on our borrowed amount. You'll notice that we're going to be dividing by the present value annuity factor. Because in the previous example, the way we were working with it was as an investment. So how much would we have in our original deposit investment on this side? And it was equal to the withdrawal amount times the PVA factor. In other words, we're switching out the withdrawal or payment amounts versus the original deposit or the original amount borrowed. So the context is a little bit different because we're doing a loan instead of an investment, but we're still able to use the same Exhibit 1D for our PVA factor. So looking at our time periods, we're going to go down to 5 years, and we're looking at 5%, so go to the column with 5%, and so we go down till we get to the 5-year row, so our factor is 4.329. Plugging in our numbers, the amount borrowed originally divided by the 4.329 factor gives us the payment amount of $1,848 that we need to make at the end of each year for 5 years in order to pay off the loan. So if you have any questions, just let me know.